Ever get that feeling where you really need to get up to speed on something kind of complex, but the thought of just like wading through tons of information is just, right?
Yeah, I know that feeling.
Well, that's kind of why we're here.
Mhm.
Welcome to this deep dive on agile testing. The idea is we want to give you a really clear understanding of the core ideas, how they actually work in practice, without getting bogged down in all the technical details, right?
Yeah, exactly. You've given us some excellent material here explaining agile testing within the broader context of agile development. So what we want to do today is kind of extract the key insights, explore how testing really is embedded in this whole agile approach, and really get to the heart of why it's so important.
Okay, so agile testing. I mean, it sounds like it should be straightforward, like testing, agile, we get it. But I think to really understand it, we need to zoom out a little bit, right? Because the materials we have here really stress that, like, understanding agile software development itself is really the foundation. So before we dive into the testing part, can you give us a quick rundown of what agile is really all about?
Agile. It's best to think of it like building software iteratively, step by step, kind of these small, frequent cycles. So instead of like one massive delivery at the end, you're releasing these smaller pieces of working software kind of continuously. And this way, you're much more adaptable. You can respond to changes much faster if, something comes up.
Got it. So small, manageable chunks delivered often.
Exactly.
Okay, that makes sense. It's almost like building with Legos instead of like trying to carve a sculpture out of this huge block of, I don't know, marble or something.
Yeah, that's a good analogy.
And our materials keep coming back to these like 4 key principles that really drive this whole agile way of thinking. What are those big ideas that we should really have in mind here?
These principles, they're so fundamental to Agile, it's worth knowing them by heart.
Yeah, okay.
The first one is customer collaboration over contract negotiation.
Okay,
Second is responding to change over following a plan.
gotcha.
Third, individuals and interactions over processes and tools.
Okay.
And then the fourth is working software over comprehensive documentation.
Okay, let's break those down a little bit. So it sounds like it's really all about being flexible, right? Really listening to what the customer actually needs, valuing the people who are doing the work more than just rigid procedures. And at the end of the day, making sure you're delivering something that actually works, right?
Yeah.
It's almost like common sense when you lay it out like that.
Yeah, it is. It's about keeping things simple and focusing on what really matters.
Okay, and the sources also mention like some of the popular frameworks that teams use to actually put these principles into action, like Scrum, Kanban, these things, right?
Exactly, yeah. Scrum, Kanban, and extreme programming, or XP. Those are the big ones that come up all the time. And what's interesting is that, they each have their own specific ways of working, like their own little quirks, but they all share that same fundamental agile DNA, rapid development, adaptability, that constant feedback loop to make sure things are on track.
Got it. Now, this brings up a really important point, right? Because, if you're developing software so quickly, these smaller increments, how do you make sure that speed doesn't mean you're sacrificing quality? Like, how do you make sure that the stuff you're putting out there is actually good?
That is the million-dollar question, isn't it?
Yeah.
It's all about balance. So
Yeah.
how do you keep things running smoothly, make sure things are reliable, even when you're moving fast? And that's where agile testing comes in, and that's what we're here to dig into.
Exactly.
Now, the materials you provided are very clear that agile testing is a very different animal from how testing used to be done.
Okay. So what's that main difference that we need to understand?
It's all about when and how the testing happens. In a traditional approach, what they often call waterfall.
Yeah.
Testing is this big phase at the very end,
Oh, okay.
after all the coding's supposedly finished.
Yeah.
So it's kind of like building an entire car and then taking it for its first test drive.
Oh, that sounds a little risky. Imagine finding out the brakes don't work after you've built the whole thing.
Yeah, exactly. And Agile flips that whole model on its head.
Okay.
Testing isn't a final gatekeeper. It's woven into the entire development process.
Okay.
It's continuous. It happens alongside the coding. It's not just an afterthought tacked on at the end.
Makes sense.
And what's really important here is that the testers are part of the same teams as the developers. We call them cross-functional teams.
Okay. So it's a much more integrated and collaborative effort. Yeah.
Exactly. And it starts from the very beginning.
From day one.
Yeah.
And the benefit of getting testers involved early, according to our sources, is pretty significant.
Absolutely.
Right.
By bringing testing in early, you catch potential problems way sooner,
Yeah.
which dramatically reduces the amount of rework needed later on. So ultimately, it saves a ton of time and resources.
Makes sense.
Imagine you're building that car again. It's like having quality checks at each stage of the process rather than waiting till the very end.
Right, right, right. Yeah, that makes a lot of sense. And the sources even use this term shift left testing, which I guess is all about moving those quality checks earlier, right?
Exactly. Shift left testing is all about doing quality assurance activities way earlier in the software development lifecycle.
Gotcha.
The idea is that by addressing quality from the outset, from the get-go, you prevent these issues from becoming bigger, more complex, and more expensive to fix later on.
Makes sense. It's proactive, right?
Exactly. It's proactive quality.
Okay, so agile testing is continuous, collaborative, starts early. Got it. But what does that actually look like in practice? On the ground? Our materials detail some key techniques that actually make this stuff real. And the first one we want to talk about is test-driven development, or TDD. Now, this sounds kind of backwards to me. It's writing the tests before you even write the code.
Yeah, no, at first it seemed a bit counterintuitive. But
Yeah.
TDD is a really, really powerful technique. The basic idea is that the developers, they write these automated test cases before they write the actual code for a feature or function.
Okay.
And this forces them to really think through the requirements and how that code is supposed to behave up front.
So the test essentially becomes like a blueprint or a mini spec for the code that's going to be written.
Yeah, you can think of it like that.
Okay. So what's the real advantage of doing it this way? I mean, is it just about making sure you know what the code should do before you start writing it? Or is there something more to it?
Well, that's definitely a big part of it. Clarity, having that clear understanding of the requirements up front is huge,
Hmm.
but it goes deeper than that. By writing the test first, you're inherently making sure that the code you're about to write is actually testable. It's also like a built-in quality check as you go, right? It helps prevent defects from the get-go
Mm.
because you're validating the code as you write it, not as an afterthought. So,
Okay.
for example, if you're building a function to add two numbers,
Okay.
the TDD approach would have you first write a test that asserts that, 2 plus 2 should equal 4.
Right.
Only then would you actually write the code to perform that addition.
Gotcha. Now, the sources also mention this red-green refactor cycle. It sounds like kind of little mantra for TDD. What is that all about?
Yeah, think of it as this tight little iterative loop. Red is when you write a test for a new piece of functionality, right?
Okay.
And because the code doesn't exist yet, the test fails. It's red.
Okay.
Then you move to green, where you write the absolute minimum amount of code to make that test pass. You're not going for like perfect, elegant code here,
Yeah.
just enough to satisfy the test to get it to green. And then finally you go to refactor. This is where you look at the code you just wrote and see if you can clean it up. Can you make it more readable, more efficient? And while you're doing all that, you're making sure that the test still passes. It stays green. So it's a cycle of continuous improvement at this very, very granular level.
So it's like write a failing test, make it work, and then clean it up.
Exactly. Write a failing test, make it pass, clean it up. That's TDD in a nutshell.
Perfect. Makes perfect sense.
Okay.
Now, another practice that our sources highlight is continuous integration, or CI. You hear that term a lot in the tech world. What's the core idea behind CI?
CI is all about developers merging their code changes into a shared repository very frequently, like ideally multiple times a day.
Okay.
And the crucial part here is that it's automated.
Got it.
Every time code is committed, a build process kicks off automatically, and then a whole bunch of automated tests run right away to catch any integration issues or conflicts, like right there and then. So think of it like a central hub where everybody's work comes together constantly, and you've got these automated checks making sure everything plays nicely together.
Okay. So it's like catching problems early and often before they can snowball into these huge things. And the sources mention some tools that help with this, things like Jenkins or GitHub Actions. What's the role of those tools in this whole CI process?
These tools are the engines that make CI really work. They do the heavy lifting of automating everything.
Gotcha.
So they monitor the code repository, and as soon as a developer pushes their code, the CI system automatically builds the application, runs all the predefined tests, and if any of the tests fail, the team gets immediate feedback like, hey, something broke, go fix it right now.
It's like having a little watchdog that's constantly on guard duty, making sure everything is in order.
Right. It prevents those horrible situations where different developers' code clashes unexpectedly at the very end of a project, which, believe me, you do not want to experience.
Yeah, that sounds really painful. It's like, it works on my machine.
Exactly, yeah. You want to avoid that scenario at all costs.
Yeah, for sure. Okay, let's move on to something that sounds a little less structured. Exploratory testing. That almost sounds like, just messing around with the software.
It might sound informal, but exploratory testing is a really valuable and skilled activity.
Okay.
It's where testers actively investigate the application,
Okay.
but they don't rely on those pre-written, super detailed test scripts.
So it's more free form, right?
Yeah, it's a bit more free-form. They're thinking critically, asking questions, and really using their intuition and their understanding of the software to uncover potential issues that you might not find from a rigid test plan.
So it's like going off the beaten path, looking for those unexpected things, hidden flaws.
Yeah, exactly. And they can think like a user, try different things, and see how the application behaves in those, like, less common scenarios.
Okay, and the sources say it's really good for finding usability problems and security vulnerabilities. Why is that?
That's right. Because exploratory testing is driven by that human curiosity. By learning, testers often find issues that automated tests or even strictly scripted tests just miss. They can think like a user, like, but what if I try this unusual combination of actions?
Right, and it breaks.
Yeah, exactly. And then boom, you find a bug. This human element is really key for uncovering those usability problems, things that might be confusing or frustrating for the end user. And also, they might stumble upon security weaknesses that weren't explicitly covered in the requirements.
Interesting. So it's not just like randomly clicking around. It's informed exploration guided by the tester's knowledge and intuition.
Exactly. It's like a detective investigating a case. You follow the clues, you use your experience, and you see where it leads you.
That's a great analogy. Okay, and the last key practice that the materials we have here highlight is behavior-driven development, or BDD.
Okay.
And this one sounds like it's specifically trying to bridge the gap between the technical folks and, well, everyone else involved in the project.
That's a really good way to put it. BDD builds upon those principles of TDD, but it takes it a step further. It focuses on describing the expected behavior of the software in a way that everyone understands, not just the developers and testers.
Got it. So how does it do that?
It uses plain, natural language
Okay.
and a very specific format. It's called the given, when, then format.
Given, when, then. Okay, break that down for us.
So the given part sets up the initial context or conditions.
Okay.
The when describes a specific action, like what the user does or what the system does.
Got it.
And the then describes the expected outcome, the result.
Got it. So that sounds like it would really help with communication and just make sure that everyone's on the same page.
Absolutely. By using this common language, this very human language, BDD fosters better collaboration between testers, developers, and even business stakeholders, the folks who maybe don't have a technical background.
Yeah.
And it just makes sure that everyone has this shared understanding of how the software should behave in different situations. And the sources even mention tools like Cucumber and SpecFlow that can actually automate these plain language test specifications so they become like executable tests.
Okay, so it's like making the tests a form of living documentation that everyone can read, understand, and even contribute to.
Exactly. It's a way to bring clarity and transparency to the whole development process.
Okay, so we've covered a lot of ground here. Agile testing is this continuous integrated approach. It emphasizes collaboration and leverages these practices like TDD, CI, exploratory testing, BDD. It definitely sounds like a pretty big shift from the old way of doing testing.
It is a significant shift.
Right.
And it's a shift for the better.
Okay. So what's the big takeaway for our listeners here?
Well, the big takeaway is that Agile testing isn't just a trendy buzzword.
Yeah.
It's an absolutely essential practice for any team that's doing Agile development. It's about building quality into the product right from the start, rather than trying to fix it at the end. It's like baking a cake. You don't just add the sugar at the end, right? You mix it in from the beginning to make sure it's evenly distributed throughout the whole cake.
Right. Yeah, that's a great analogy.
And that's what Agile testing is all about. It's about making quality a part of the recipe from the very beginning.
Perfect. So, for you, the listener, Agile testing is about continuous validation, catching those bugs early when they're easier to fix, and using automation to make it all happen smoothly.
Right.
The big things to remember are test-driven development, or TDD, continuous integration, or CI, exploratory testing, and behavior-driven development, or BDD. Keep those in mind.
Now, all this leads to an important question for you to think about. How can these Agile testing principles transform your approach to software quality and how fast you can deliver great software? Imagine applying TDD to ensure clarity and prevent defects early on. Picture using CI to automate all those tests and integrations, making sure nothing breaks unexpectedly. Think about incorporating exploratory testing to have that human touch, to uncover those subtle usability issues. And envision using BDD to foster collaboration and build a shared understanding across the team. This isn't just about a different way of testing, it's a whole new way of thinking about building software. It's about making quality an inherent part of the process from start to finish.
Great advice. Really appreciate you taking the time to break all this down with us today.
My pleasure.
And to all our listeners out there, thanks for joining us for this deep dive. And until next time, happy testing.